Hello, good morning, everyone. So we'll be able to start this week's session in the next 5 minutes. So, okay, so good morning once again. We'll be able to start today's session. We'll have it in two parts. We'll have the main part of the presentation being taken by Sarah Mumbua, and then we'll have the second part being solutions that Keton offer, which will also be another 15 minutes presentation where we talk about Keton's solution offerings to histology. So I would wish to welcome Sarah Mumbua to start us off so that we can maintain time. And thank you once again for making time and joining our webinar series. So, Sarah, take it away. Thank you.
Thank you. Good morning, all who are present. Again, my name is Sarah Mumbua. I head the histology department in JTRH, and I'm honored to be in this session today. Today, we'll just explore on how integrating lean principles into tissue processing can transform our laboratory workflows, making them more efficient, accurate, and responsive to diagnostic needs. If you're here maybe to learn or collaborate or just to refine your own laboratory practices, this session is designed to offer practical insights and actionable strategies. We're just going to go through the tissue processing. Those who have worked in the histology lab, those who are working in the histology lab already know. Histopathology is a cornerstone of diagnostic medicine. But most of the time, it's plagued by inefficiencies, delays, errors, and bottlenecks. So today, we are going to learn how lean methodology, either through the manufacturers and the focus, how we're going to focus on eliminating waste and improving on the workflow. So today, we'll walk through each step of tissue processing and explore how lean principles can be embedded into to create more eligible and reliable workflow. I hope you can hear me well.
Yes, please.
Okay, let's continue. So the very first step here, we're going to do when we receive the tissue. That is the key point. Once you receive the tissue from wherever, tissue may only come from the theaters, come from the outpatient clinics, come from referrals. So your first step is to check on the tissue reception. There's a criteria on specimen, just like any other department, the specimen reception criteria. It comes down to this tissue from histology lab. So first thing first, you have to verify that the sample or the specimen is properly fixed in 10% neutral buffered formalin for at least a minimum of 8 hours. In our books, we said 30 times the solution, but you can just make sure it is properly immersed into 10% buffered formalin. This is very essential to preserve the cellular components of the tissue. So in that, when we are still checking on the sample registration and the sample reception, check on the request form. If it is well documented, well filled, the credentials of the patient, that is the names and the age and the sex, some at least clinical information, whether they have done any investigations like, for example, we are talking on a biopsy from the prostate sample. So you want to check whether they have done the PSA levels, that is the blood works, check on whether the imaging has been done, and then report on that, like the ultrasound report, the CT scan report. This information will help during the reporting of the slides. So the checklist is make sure the documentation is well done, details of the patient are well done, and the request is fully filled, just in short. Another thing to check is also check on the container, just to be intact, no leak, it should be leak proof. we are trying to make sure that you're not exposing people to formalin, because there's something called formalin exposure per day, per hour per day. We want to maintain that as much as you are working in the laboratory lab, in the histopathology lab, make sure you're not exposing any form of formalin to the environment for your sake and for the sake of the rest of the team and even the patients. So once you receive the specimen and gone through the rejection criteria, rejection acceptance criteria, you can now give it a specific, a unique accession number. This is very key because remember, this tissue, once you're moving it from one step to another, does not carry any documentation, any other thing. So this unique number is what will move with from the very first step to the last step. So you can, if you have the LIS system, make sure to log it into the system. If you don't have, I don't know, you can do the documentation in the books, your tracking logs, tracking books. So once it is you confirm the sample is acceptable and good to go, give it the unique number. Then this number, you can link it to the system, give it to the request form, give it to the sample. And if the patient has maybe the receipt and anything else, you can still add the number there, so that whenever you'll be tracking their results, just by the number, you can be able to check where it is. So here we're going to make sure, if some labs are still advanced they have even the barcode scanning. If you have so, the better. If not, just you can do the writing with a pen or a pencil. Then now on to our next step, which is the very key. This is done by, the next step is tissue grossing. Mostly it's done by a pathologist, but not necessarily. Even a pathology assistant, a histotechnologist, even a lab technologist that is experienced and trained can do the tissue grossing. Because here there's not much, we are just checking on the macroscopic examination of the tissue. Just check on the size of the tissue, what color it is, the contours, the texture, the weight. If, for example, it's an organ, you want to weigh it, check on just the macroscopic examination of the tissue. Making sure you make documentations, when we have the ideal grossing session, some have like a recorder where you can just dictate the notes and it is speaking. If you don't have, now you can use a tech or someone else to document for you the grossing notes. Mostly, this one will help you during the microscopy to help on the pathologist to know what was the tissue, how big was it, what color was it, did it have any calcifications. If there are calcifications, you can put on light decalcification or the normal decalcifying solutions. So in this step, we are going to require a few things. We are going to require like a measuring tape or a ruler. We are going to require the weighing scale or weighing balance. We require the grossing kit, that is the knives and the forceps and what we call it, even as much as even axle and I don't know, a mallet or what. If you have for example, we have a limb, amputated leg, you will require now something stronger to cut it into smaller pieces. So in this part of tissue grossing, a lot is, yes, grossing knife. In this step, we have some tissue is too big, like we have a mastectomy specimen. You do not expect it to have fixed just normally just by immersing it in formalin for 8 hours. So here you can do bread loafing, like that. If you slice it in just the way you slice a piece of bread in smaller pieces, then allow it for a longer time to fix better. If you're dealing with maybe that, whatever I've said, an amputated leg or a bigger tissue, make sure to make it smaller so that the formalin can mix well. So I did say we require here a dictation, the templates where you now, like, you can just be ticking where you require. Most labs make the dictation templates unique for each specimen. For example, you're dealing with a uterus. You make a template that requires what type of specimen is it? Did it have the fallopian tubes? Did it have the ovaries? Just tick. Then how many slides did you make? Did you have lymph nodes? Those kind of things. So this step can be done by even a histotechnologist, even the lab technologist, if you're exposed and you're trained. Just a continuation, we'll now label here we require the tissue cassettes, which are of different sizes, different colors, different color codes. If a tissue is that some tissues that are too tiny, like the prostate cores and the breast cores, even some punch biopsies, some skin punch biopsies, some endometrial curettings, you require a smaller meshed tissue cassette. Some labs code them according to colors. You can see the breast take pink, the cervical take this color, but there's no much big difference even if you use just same color for all of them, as long as you use appropriate tissue cassette for appropriate tissue sample. If it's a smaller sample, put it in a smaller meshed tissue cassette. If it's a bigger sample, put it in a normal cassette. The other things, like you find some labs have the what do we call them? We call them the pouches and the biopsy pads. For those smaller tissues, you can place them there. If the worst comes to the worst and you do not have the pads or the pouch, you can use a filter paper. Just place the tissues on the filter paper. Wet the filter paper, place your course onto the filter paper, close it, put it in the tissue cassette, then you're good to go. It's not going to get lost on the integrity, it's just going to remain intact. Then onto our next step, which is now the main thing. Here we are going to do the actual tissue processing. These tissues they are flesh. It's a tissue collected from human body, so it's made up of water. The formalin, also the 10%, we are making the 10% buffered formalin. I'm assuming everyone is aware of how to make them. And mostly in almost labs, make sure that you have a small template, a small job aid on how to prepare 10% buffered formalin. That has to be readily available all the time, because some samples will come in not well fixed. So it's up to you when you're checking. Unfortunately, I forgot to tell you guys when we were starting on sample reception, sample for histopathology or histology, you cannot. Yes, you're allowed to reject, but you can't reject in like the rest of the samples. Here you reject, but you make corrections. If it's not well fixed, do the fixative. If the container is not right, change the container. If the request form is not fully filled, consult the doctor or the clinician or the person who's supposed to fill it. Make sure it is fully filled. So in this step, we are going now to remove water from the tissue, because we want now to start our processes. Now the next steps do not mix well with the water. So our very first step is dehydration. And in this case, we are using alcohol. When I say alcohol in histopathology, put more emphasis on ethanol. I mean ethanol. So we are going to use ethanol in descending order of alcohols, from absolute alcohol to 95. You can do changes anyway. If absolute alcohol, you can do like 2 changes: 95%, 85%, 75%, and 50%. We just want to be. I'm sorry, I did it the other way around. So we are dehydrating. We are going to start from the lowest concentration of alcohol, 50% going upwards. So the last step we'll do absolute alcohol. Hope I'm clear there. We are doing dehydration, so we are removing water from the tissue. We start from a lower concentration of alcohol. That is 50% alcohol going upwards up to absolute alcohol. And we already agreed why we are doing the dehydration. We want to remove water because most of the next steps do not, in fact, all of the next steps do not agree with the water. So the next, after we are done dehydration, we'll do clearing. Clearing is just simply like removing the alcohol now, because even the next steps here do not agree with alcohol. There are many, we learned in school, many clearing agents, but in this case, what we'll use mostly is xylene. So clear using xylene, several changes. You can do 2 or 3 changes of xylene. Just we're trying to make it like, just to be quality. Like when you're rinsing your clothes at home, you do like several changes. It's not like if you rinse once, it will not be clean, but if you rinse more, it's going to be better. Then our next step is tissue infiltration or impregnation. In this aspect, we're trying to give the tissue some internal support. We assume it has some small pores, some spaces that need to be filled up, because during microtomy, remember, you'll be using a very thin sections. So we have to make sure every part of the tissue is fully filled. So we just immerse it in paraffin wax, molten paraffin wax. In this case, the temperatures are slightly above the melting point of wax. So depending on the wax you're going to be using in your department, if your wax melting point is between 54 to 55, you can do around 60. If it's between 56 to 60, you can do 65 to 70, around there. So this step, mostly it happens in the tissue automated ATP, the tissue automated tissue processor. But nevertheless, if you do not have the automated tissue processor, these steps are all doable manually. You can have the jars fixed, a few jars with alcohols, the next ones with dehydrating solution, that is the next one with clearing agent, that is dilene changes, and the next one with the molten paraffin wax. Yeah. So once we are done with the tissue processing, which I've said most of the time is done on an automated tissue processor, we've given the tissue is now, it's free from water, free from alcohol. It is well impregnated with paraffin wax. It is good to cut, but now it is too small still to cut with a microtome. So we want to give it some external support. This one we're going to do it using this process is called embedding or doing blocking. This one we want just to give the tissue outer support, so that when you're doing microtomy, it is going to be easier, it's well supported, and it's not going to fall off. In this, most places, in the ideal setup, it's an embedding station. Embedding station is composed of a cold plate, a hot plate, and a wax dispenser. The components here, we are going to require the tissue cassette that has the specimen from the tissue processor, then the tissue molds, forceps, and the molten wax. So the steps here is very simple, just using the tissue mold, fill it up to the base. It is usually like, it is, if you've seen it before, there's even a small picture, the pink, there's even a small picture if you can see this one, the pink, where the pink tissue cassette is placed, is the tissue mold. So just fill the tissue mold with the wax, pick the tissue from the tissue cassette with the forceps. Now these forceps, everything here is put in the warm or the hot plate. So pick the tissue place the tissue onto the molten wax at the tissue mold, then place the cassette bottom down, then top up the wax up to be full. Then you can let it dry, cool. That is when we are requiring a cold plate and a hot plate. Once you dispense your wax, you put the tissue, you place on the cover, you place the cassette on top, just let it cool on the cold plate. There's some labs, if you do not have the cold plate, you can use some ice cubes or even the freezer, at least negative 20. And now your slides are good. I did mention there are two main areas I want you to put keen on during tissue embedding. Make sure you do proper tissue orientation. Some tissues are circular, some tissues have layers, some tissues are tubular. Make sure those orient the tissue well. Make sure it is well placed at the center. Make sure if it's circular, all areas are being covered. Make sure if there are some tissues usually written block on edge. You want to make sure the edge is the part that is at the top or the place where you're going to cut. So make sure you're doing tissue orientation well. Choose appropriate tissue mold. If your tissue, for example, you were doing your tissue was the mastectomy or the uterus and the fibroids, it's bigger. So you cannot use a smaller mold because the tissue will go like out of the mold. So if you're doing cores and the small patch biopsies, use a smaller tissue mold. So in this aspect, make sure there's no air bubble, make sure the tissue is well oriented, and make sure you've used the appropriate, the right tissue mold size. Another key thing in this point I have also to emphasize is you can only do one specimen at a time. You can't embed Like you remove this tissue from the cassette, you're doing it and you're doing another one, you cannot do that. Remember, the specimen itself has no label, has no name, or has nothing. So you're depending on the label at the tissue cassette. So if you, by any chance, you mistake this cassette with this cassette, you are done. Because there's no way you'll be able to differentiate which tissue was in which cassette. So always make sure you embed one specimen at a time. Hope I'm clear there. Once we are done with embedding, now we are good to go. This is where the magic in histology happens. This is where the technique happens, where the expertise comes in. This is like more, do I see a skill, or like you have to get to know to do how to do this. Microtomy, it's not, it looks so easy, it looks like we're playing with something, some machine, but this is where the real histopathology lab work begins. Here you have to cut the section so thin, you need to at least 3 to 5 microns. So we can set your if you have a microsome that is semi-automated or automated or manual, just make sure to set either 3 or 4 or 5, depending on the tissue size and the tissue, whatever. There are some things here, some doctors will request for betas, some doctors will request for thinners, some doctors will request for these kind of things. So depending on what you want to do, set the microtome at that thickness. If you want to do 3, or you want to do 4, or you want to do 5. And here we are making sure the blade is very sharp. It's brand new, in short. Because if you use a knife or a blade that is not so sharp, it makes the tissue to chatter. And those chatters, when you place them on the water bath, you want to make slides, they'll appear so bad, so different. Even during the stain, they'll not be nice. So this procedure, mainly you have to practice, mainly you have to do it, it's hands-on. Microtomy is the cornerstone of this, is the whole part of this, the tissue processing. You just cut the thin sections. Once you've cut a serial of a section, place it on a water bath that is at least temperature that is below the melting point of wax, so that you'll be able to fish out using a clean, grease-free slide. Some labs will even go to the extent of using charged slides, but the charged slides you can leave it for histochemists in such in special stains. So in this category, mainly it's more of practical. In this microtomy part, it's more practical. You have to get the microtome and work on it. Then you will be able to know how to use it. After we are done with microtomy, here we've made the sections. We are good to go now. But remember, these sections were embedded on wax. We are not interested in the wax anymore. We're going to remove the wax so that we can do staining. So in this part, there is what we call dewaxing. Just place the slides on a drying rack or oven. I do not want to say bake them, but put them in 60 degrees for 1 hour at least, at most 1 hour. This one you're going to, it's just you're putting them on a hot plate to remove the wax. Wax we are done with, and I forgot to tell you, we learned in school we can use the, what do we call them, the adhesives while fishing and placing the tissue on the slide. With experience and having worked in the histopathology lab for some time, I know even minus the adhesive, the tissue will still stick. If you fish it right and you're using the right tissue, the right microscope slide, it will still stick. So we did not, in our setup nowadays, we do not use the adhesives anymore. But if you have them in your lab, you can still use it. So during fishing out, you can apply the adhesive onto the slide, then fish at 90 degrees. That is good to go. If you do not have the adhesive, well and good, you can still fish without it, it will still stick. So now we are done with the wax. We want to be done with it so that we can stain our slides. So do the dewaxing using an oven or a hot plate or a drying rack for at least 1 hour, at most 1 hour at 60 degrees. Once we are done with the dewaxing, I know there are still some wax that will be remaining there. So do something known as defarthinization. Some good labs have the station, departmentalization station. If you do not have, worry less. some of these, even the auto stainers, some are incorporated with the deparaffinization chambers, like the section is already fitting in the deparaffinization is already fitting into the staining auto stainers. If you don't have the auto stainer, you can have the chamber outside, have the jars of the orders of 3 changes of xylene, orders of alcohol, and lastly, water. Here, remember during the tissue processing, when we are setting our processes, we removed all water from the tissue. And now we want to stain with the hematoxylin. Hematoxylin is water-based. We have to introduce the section slowly into water. That is why we are going to, once we are done with removing the wax, that is you done with oven, 1 hour at 60 degrees. Rinse in xylene 3 changes. You can do dips, just a few dips. Some of the automated processors are timed. You can do 5 minutes each xylene, or just 5 minutes, 5 minutes, 5 minutes. When you do dips, it will still work. Then go to ascending, to descending order of alcohol. When I said when histology, when I'm talking about alcohol, always put in your head, you're talking about ethanol. So do from absolute, 95, 85. It's not standard, it's not cast on stone. You have to do 95, 85. Just do that order of from high concentration to a lower concentration. You're going to introduce the specimen into water because you're going to stain with the hematoxylin that is water-based. So here we are going to do our staining. I said most labs have the auto stainers. If you do not have the auto stainer, you can always you can always do the chamber. You can always have, you can improvise, you can buy. There are some that are already, you can buy in the market that are well set. They have jars inside and it's a metallic chamber that has those jars inside, as many as you require. So we are going to use eosin, hematoxylin and eosin is a routine stain for histopathology. There are many other stains, like the special stains like the gram stain, the ZN, the PAS, GMS, and many others. Even in histochemistry, it's part of a special staining. So here we're going to talk mainly on hematoxylin and eosin stain. So I said when you're using the automated auto stainer, you just load the tissues, the slides on the rack, then the machine will do the real thing for you. If you do not have the auto stainer, just do the dips. The first dips will afterwards you clear the wax, do hydration or bring section to water, then stain with the hematoxylin. The book says 7 to 10 minutes. Check what will work for you. You will have to do control runs for the staining, so that you'll be sure. If I do 7 minutes, it will work for me. If you're doing remember you're doing you're overstaining with hematoxylin, then before you do the counter stain, you remove the excess hematoxylin by using 1% acid alcohol. Then you blue. You can blue with even tap water. If you do not have the blue agents, you can blue with tap water. Then you counter stain with eosin, which is our routine stain here. I hope you guys know you people know the staining principle of hematoxylin and eosin. Here we are targeting the tissue cells, as well as the basic part and the acidic part. The acidic part should be stained by the basic part of the stain, and the other way around the same. So this one you have to be sure. For us being the technical people, that is when we are doing the staining, you know which cell to pick, which part of the cell to pick, which part of the stain. And that one you can check microscopically once you're done with the staining. So the next, not the last step, we are doing is mounting. There are many mountants in the market, but you can use DPX. Even the aqua mountant, I saw it still is in the market, but you can use DPX if you do not have the aqua mountant. So here you're using a cover slip, that is, histopathology cover slips are usually bigger than the normal cover slips. If you do not have them, you can use the normal cover slip, but depending on the size of the tissue on the slide, use 1 or 2 cover slips. So You do mounting. It's the bigger deal here with mounting. You just want to preserve the slide. The tissue is good for microscopy. The refractive index is fine, but you have to cover it with a cover slip just to protect it, prevent it from being like distorted or destroyed by any other thing. Remember, these tissues, these slides are permanent slides. You can even the test is not like cut on. If this doctor says you have this diagnosis, it's not like that is the final diagnosis. You can always, the patient can always request for a second opinion. So if the slide has to be put shipped to another lab or to another doctor, then they need to be preserved well. So once we're done with the mounting, we let the slides dry and they are ready for microscopy. Some labs have digital pathology, whereby you can just scan the slides. Once you are done with the mounting, the slides are dried up. Just scan the slides, upload into the system, send to the appropriate doctors, and they can even share with their fellow other doctors in other labs. If you don't have the digital platform, just the slides are ready for microscopy. This is mainly done by the pathologists. I know most of us are fighting, we're thinking maybe, why are the pathologists coming to report slides in our labs? But I don't take it as a big deal. I think that's okay. You already have much to do. Remember, you're doing all these processes. It's not like you're doing the donkey work, but you're doing actually the technical part. So the pathologist is going to do the review of the slides. And this one, you make sure you arrange them in numbers, in order. Remember, the very number we gave the tissue from sample reception is the number we gave at the tissue cassette, is the number we are giving at the slide. So I make sure that these numbers are exactly the same, are matching completely. So you arrange your slides, your request forms that are fully filled, and your reporting templates, take it to the pathologist. If you're doing the digital pathology, upload into the system the slides and their lab numbers and their request forms. That is good to go. Then here the pathologists will do their work, let them report the slides, and you can get your reports. Our last but not least main part of this work. Remember, always we are lab techs, we are lab people. Make sure to do quality control on your histopathology. From the very first step, make sure you're doing quality control on your, because you are, remember here, quality control is not just catching on the mistakes. We are about building systems that will prevent the mistakes. So from tissue specimen reception to the slide scanning, each step must be governed by a clear standard. Make sure you have SOPs. Follow the SOPs up to the latter. Make sure you follow, like if you say fix in 10% buffered formalin for at least 8 hours. Do not go short of that. Do not bypass some of these steps. Make sure from step 1 of tissue reception to the last step of slide scanning or dispatch to the pathologist, and you have to make sure you've seen the slides yourself with the microscope to make sure they are well stained. If they do not have water bubbles, don't have any bubbles, they do not have water, they are good slides. You even be able to see and able to tell. And even during our staining, make sure you stain a quality slide also. Most of the places we use the appendix tissue to make control slides for staining. It stains best with the hematoxin and the eosin. So once you've done the appendix tissue, process it normally. Then during staining, you use one slide for staining. Then you see how the slide appears in the microscope. So when we are still talking on the QA part, from the reception, make sure the patient identifiers match. That is a quality check. Make sure your specimen is intact. The specimen is not soiled, the container is not soiled, and it's well labeled. Make sure the tissue is fixed in 10% formalin. And as I said, you cannot, in this aspect, you cannot reject a tissue for histology and say, now this one is because it's not well fixed or it's not well documented, throw it out. These specimens, you cannot, some of them you cannot rebiopsy. Maybe someone they have done a mastectomy, they have followed the whole breast. If you say it is not well preserved, it's not well documented, and you throw it, where else are we going to get another specimen? So as much as even that you're rejecting that sample, but you cannot like discard it. Reject and take action. Take action, make sure it is whatever was lacking is now, look for it. If it was not well filled, look for someone who's supposed to fill it. If the specimen was not well preserved, preserve it. If it was the container was wrong, you can change the container. During registration, make sure, like if you are doing the barcode scanners better. That one there are minimal errors. If you don't have the barcode scanners, make sure you fill the mandatory fields. When you are logging a patient into the system, you have to make sure the credentials of the patient are accurate. If you miss out, imagine you miss out a detail. You're calling a patient with a CS cervix, then you say male. Then you send that report to the patient. The patient will even wonder, was this even my result? So make sure the credentials are well filled. So in registration, quality control ensures that every specimen is digitally traceable. Barcode scanning and mandatory fields reduce human errors. Just what I've just said. You cannot say someone as, like, you have prostate CA and you're a female. Maybe you have cancer of the cervix and you're a male. Make sure this human error is done with. And during grossing, in the same way, make sure you slice thin sections, at least 4 to 5 millimeters. And there's something I didn't mention about marking inking the margins. If, for example, a tissue from the, let's say, about a segment of colon has been collected, you want to ink the margins, so that the pathologist will be able to know what the margins have any tumor or not. If it's a breast tissue, or most tissues, you want to ink the margins to make sure that once the slides are ready, the pathologist will be able to tell, did the tumor extend the margins? Did it extend more than what was collected or not? This is going to help even the managing doctor to know whether they left something onto the patient or they collected everything. But during tissue preparation, also what I said, make sure your tissue cassettes are labeled correctly. You cannot label this cassette for this patient, then the other one for another patient. Make sure if, for example, one tissue has several tissue cassettes, like you are using a bigger tissue, you want to make several cassettes, they have to be exact numbers for not all of them. If you want to number them like several, you can do 1, 2, 3, up to 10, but the number has to remain the same. Because in this level, this is where you can make a mistake that is not correctable. If you miss out the tissue and place it on a cassette that did not belong to that patient, that you're done now, you will not be able to correct the mistake even in the next steps. So in this area of quality control during the tissue preparation, we have a tracking sheet. Tracking sheet is just to remember to document down this patient sample, this patient number, and this number of cassettes, and this number of cassettes are for this tissue. And this is traceable all through. Even when you are dispatching your slides, you know this patient number this had this number of cassettes. So they should correspond to the number of slides you're going to dispatch for microscopy. Then during tissue processing, you have to make sure that the solutions, we are using a lot of solutions, they are fresh. If you're using 10% buffered formalin, it is freshly prepared. If you're using when you're using the xylene, they are freshly put. When you're using the alcohol, they are freshly prepared. What you can do is track them. How many samples do I need to run to change them? Like if I say I will be changing weekly or after 2 weeks, maybe I didn't even run much. Why am I changing? Or even in these 2 weeks, I ran so many tissues. So what you're going to use to make sure to know how you're going to change your reagents is on the number of tissues you've processed. If you have processed, for example, 1,000 cassettes in 1 week, I cannot say I'll still change in 2 weeks because this number is too much already. Remember these solutions, these machines, the tissue processors, some are put in a way that the tissue is on a fixed station, the solutions will find it there. If you're doing clearing, xylene will come and find it on the stationary point. So remember, this xylene is mixing these tissues over and over and over. So you have to change it after some time. Make sure you track how many samples have I run. So if in your lab you put like I'll change in every 1,000 samples or even every 200 samples, track the samples. Have a tracking log to say that I've used this, I've done like this 2 weeks, I've done 200 samples. So now it's due for change. Don't wait, don't say actually I change weekly or after 2 weeks or monthly, because that will be lying. It will depend on how many samples you've run. That is how you can be able to tell how many times you change the solutions. And during embedding, make sure your wax is not, do not cook. Here, you hear these slides are cooked. You hear some of these comments from the doctors. The slides are cooked. We can cook here because you're using a hot plate and the wax is also molten. So make sure here you do, and here make sure you use a good, correct tissue orientation. Do not, for example, what I said about blocking on edge, and if you don't check on the tissue type, do not do a correct work. So make sure you check if the tissue is, and these things are noted during grossing. During grossing, make sure to write notes. It's a tissue for blocking on edge. It's a circular tissue. It's a tiny tissue. Some tissues, some endometrial curettings are so, what do I say? They are so like water-like or liquid. So make sure if you place them on a cover on filter paper. During embedding, make sure to remove. I have seen someone do embedding with the filter paper on. How are you going to cut the filter paper with the microtome? So make sure during embedding, you do a quality check. Are my tissues well embedded, oriented? If it was circular, is it well placed? Are all areas of that circle, like the eye? You have to make sure all parts of that eye is being seen. If it's tubular, like the fallopian tubes and even the intestines, make sure all levels are being seen. If it's skin, for example, skin has layers. Are all layers being able to be viewed by the microscope? So this is very key. And in microtomy, where I say this is the actual magical part in histology, do not make sure there are no chatters, no folds, and the thickness is even. Your blade must always be sharp. And there it's not standard that you do two or three blocks, cut 3 blocks, and change the knife. No, it's not standard. It's not cast on stone. Just do it and you'll see. If it gets blunt, change the knife, change the blade, so that you avoid the chatters, you avoid the folds, and make the tissue to even. Staining, that one I already said. Use an appendix tissue. If you're doing the normal H&D, stain it with the normal procedure. You'll be able to appreciate it in the microscope. When you check how it will stain, you'll see how the background will check, how the cells will check. So always make sure to use a control slide when you're doing the staining. During mounting, I just say two aspects. Make sure there's no air bubble, and the cover slip is of good size. If the tissue is bigger, use the normal big cover slip. If your tissues are smaller, you can use a smaller cover slip. The ones you're using is in other benches in the parasitology and that. Always make sure you have a stain performance log. Just like we've done with the tissue processor, here also have a log on how many tissues did I run to change the solutions. Remember, if you do not hydrate well, you do not dehydrate well while doing this process, something wrong is going to happen. Because during staining, remember, we are hydrating and dehydrating. So if the alcohols are not standard, you're going to have mistakes in. Even during the digital platform, you have to scan appropriate slides or appropriate requests, then send to the doctor. You can confirm yourself first with the microscopy, then send them for reporting. Once they are reported, now it's up to you to. Some labs, I know some labs have what do we call them, like the typist or someone to do the typing of the reports. If you do not have the typist or someone to type your reports, you can type them yourself. Some doctors type them themselves and upload to the system, which is even easier. Then from there, you do archiving. These blocks are permanent blocks. The slides are permanent slides. You can keep them up to 10 years. And remember what I said, these tissues, a patient will come after 2 years. I want my tissue back. Will you still be keeping their mastectomy sample, or this, will you be still keeping their gross tissue? No. So the block is what they have, is what you have for them. If a patient comes back, I want this tissue for this other test, or I want this tissue for confirmation. Maybe they went to Prophet War and they were prayed for, and they feel they are healed, then come back later, I want to confirm them whether I'm healed or not. Whatever they require for. Some in this, where I work in this region, in the Western region, people will even say, I want my tissue for burial. So it's up to you. Just make standard. There's a standard way of disposing the tissue. If you said, for example, in your lab, you're going to do every 2 weeks, every three months, or every whatever time you put, which is standard, and you have an SOP to support your documentation, to support that you're going to dispose the gross tissue within 3 months, that is good to go. As long as you have the blocks intact, because the blocks is what the patient will require for any other thing. If they are sent for a special stain, they are being sent for immunohistochemistry, for second opinions, and that kind of thing. So your blocks has to be kept well. So if you do not have the archiving system, archiving cabinets, you can always improvise. Make sure your blocks are well placed according to the numbers. If you set it from, for example, 001, make sure 001 and 100 cannot come before 001. So make sure your blocks are well arranged and your slides are also archived well. So I said quality control is not a single checkpoint. It's a culture. And good thing we are lab techs, lab officers. This applies to every other department, and in histology, same way. It's a culture. You have to check to do your quality control all through, from step 1 to the last step. Thank you very much, guys. Ladies and gentlemen, for listening. I'll be open for maybe more contribution and questions if any.
Okay, thank you so much, Sarah. That was an amazing presentation. We all appreciate it. So we'll go to the next session on the Keton Marketplace for the next 10 to 15 minutes. Then we'll hand over the session to Mr. Jaccodul to oversee the Q&A section. So kindly, if you have questions on the presentations, just put it on the chat box. After my presentation is done, you will be able to unmute and also ask the questions. So kindly just put your comments or the questions on the chat box. So on Keton Marketplace, so we want to go through the solutions that Keton is offering. I hope my presentation is up. Okay, so for histology, Keton Consulting has partnered with MIRE. This is a StartLab company. StartLab is a company based in US, and MIRE is a company based in Spain. They do produce histology equipments, and they are over 35 years of experience and have done over 1,000 installations worldwide. So we'll start off with the spin tissue processor. So for the first step in tissue processing, we offer a solution in automated STP, and this can come in 3 configurations where we have 1 basket depending on the workload in your laboratory, or 2 baskets if you want to process more than 240 cassettes at a go. So 1 basket can hold 120 pieces of cassettes, while the other one can also hold that 120. So depending with your lab setup, we can have that particular configuration. Then we also have 3 wax baths if we have 2 carousels inserted in the machine, or have 2 wax baths if we're only operating with 1. So this particular feature offers automated tissue processing. So if you leave it overnight, by the end of the morning, you'll be able to get your tissues done and settling in wax. You have an automated process. You have a delay process that you can set it up so that if you want by 8 a.m. in the morning to have the tissues, it will delay the start until when it starts. For this particular one as well, we have patented technology on horizontal agitation. So remember, if you are doing the processing manually, you have to agitate the tissues every time. So it makes the lab technician have to be there so that they can be able to agitate the tissues to ensure correct infiltration. So for this technology, it offers this particular rotational agitation. So while the tissues are immersed, it keeps rotating in cycles of 15 minutes clockwise, 15 seconds clockwise, 15 seconds anti-clockwise. So this particular process ensures that all tissues are infiltrated correctly. So you have tissues that are on the first part of the or the outer side of the carousel, and also the inner part of the carousels have to be mixed correctly. So this particular technology offers that. Then it also offers shaking, so that minimizes the transfer of solutions between bat A and bat B. Then for the ergonomic keyboard, so very simple instrument to operate, as can be said by the users who are currently using our equipment. So very ergonomic keyboard. You can set programs up to 10 programs. So you can have sections for small tissues, big tissues, calcified tissues, and so on. So you can set different programs and can be selected automatically. We also provide a power backup, which is a battery. So despite you having maybe a UPS or a backup system, the machine has an inbuilt backup. What does this help in is that if power goes, the equipment will allow the carousel to move to the next position without staying so much in a position that was not meant. So if we said we are putting in formalin for 1 hour and maybe power goes off at 50 minutes, it will automatically move to the next one, even if power went off overnight. So when power resumes, it will continue the process, but at least it allows you to move to the next step if power goes off. Then we have the provisions of the wax bath and can be operated at a temperature you desire, depending on the wax that we are using. And then we also have version 123, which usually comes also with a carbon filter. So at a lab, if you want to have the carbon filter, so this one will extract fumes from the containers and extract and absorb the fumes through the carbon filter, then release to the environment. Also, there is a provision where you can install a hood here and then connect it outside the environment after it has passed through the carbon filter. So the configurations are open to anyone who wishes to go through whichever unit you want. So we have the 120-1, 120-2, 120-3, and all configurations are set to according to the lab's desire. So the 121 has one paraffin bath. That means you can do only 120 baskets at a time. 122 will have the carbon filter. And 123 will have the second carousel, making you able to be able to process 240 samples at a go for very busy laboratories. Then we have the next step, which is the embedding center. So Keton offers the EC500 by MAI. And this is how it looks. So you'll have the embedding center, as Sarah had described. Then you'll have the thermal console and you'll have the cryo console. So here is where you place your blocks. And this one is frozen at -11 degrees and can be set between -5 and -15, depending on your setting at the lab. Then you have a touchpad control and the embedding center. You have the hot plates. You have an automatic heated forceps if you wish, or you can use your normal forceps and place it on the hot plate and it still be okay. Then here you have your thermal consoles where you can store your molds here, and then you can also, so here is where you store your molds, and then here is where you have your cassette. So this particular one also can have automatic turn on and turn off. So if you want, you are at the lab and you start your work at maybe 10, so you can set it up to start at maybe say 9 a.m. so that by the time 10 comes, all the sections are achieving the temperature that you desire. So just a brief video on the process. So that's the setup. So you can buy all three, or you can just buy one if you're interested in only one section. The three parts are configured differently, but they are interconnected. You can remove the blocks as you wish. and replace with whichever you wish. If you want to have more cassettes being held there. So remember that part where we are saying we can use the oven. This one also acts like that. So you can still utilize the same embedding center as your oven. So this holds up to 5 liters of beads or wax and can be maintained at a temperature of 60 degrees forever. So it has a setting where it can maintain that its particular temperature. So you have your switch plate here, but you can also have a foot pad switch if you wish. You can control the amount of wax you want by the nozzle, depending on which block you are working with. So if you are working with very small blocks, you can have the minimum setting. If you're having bigger blocks, you can increase the adjustment. So that's just the process for embedding, as Sarah had described earlier. So that's the cooling surface. We have said it can maintain up to negative 12 degrees. You can set it up to 15, but usually it's extremes, especially if your lab doesn't have ACs, it will form ice. So usually maintain at between negative 10 to negative 11. You can also adjust the switch plate. If you are working with very big molds, you can move it back or forward depending on your setting. So simply, that's it on EC. So EC350 is a simpler model that you can have only 2 sections where the integration is combined, but EC500 becomes the bigger model. So that's the dispensing console. We have talked about it, 5 liters paraffin. It has an LED light. You can have programs. You can also have timer to set, and you can fit different tweezers here that you are working with, or you can have a heated forceps if you wish. Then that's the working area, giving you a big space to work with. Then we go to the microtome. So we offer Maya semi-automated microtomes and fully automated microtomes. We also offer the blades. Then you can set up your sectioning and trimming microns. So if you're working with 3 microns or 5 microns, you can set it up on the screen. And if you are trimming, you can set up the volume as you wish. So we have different configurations. So you can be able to change this particular section, and then you can also adjust the angle that you wish to, depending on how you fit. You embedded the tissue, you can be able to adjust different angles so that you can work well. Then you can be able to remove the adapters. So we provide up to around 4 adapters, depending on the cassette that you are using. This is the trimming section, microns, and then the section. So here we can have blades, and the adapter can fit the high profile blades or the low profile blades very easily. For low profile, we fit directly. For high profile, we'll just remove this adapter, and it will be able to now fit the high profile blades for those tissues that require you to use a high profile blade. The block is also easily movable, so you can adjust the blade area. So if you're working with a blade from here to here, you can move it ahead so that you can work with the other section of the blade and so on. So if you're working with small tissues, you can have maybe 3 different angles where you can work with the blade, and you can adjust the knife holder as you wish. If you're using 10 degrees, 5 degrees, depending on your best application. Because usually we say this is specific to the histotechnologist.
It has an automated section where you can store the memory of your start point so that you can reduce the process of moving the hand wheel. So you can have a memory of all issues should start at this particular angle, and it will be able to give you the remaining travel direction and further the sectioning comes. Now that features the semi-automated and the automated microtome. So depending on which the lab desires, we can be able to provide. So the automated microtome will come with a micro control board here, and you can be able to operate it automatically. Whilst you set your settings, it will just do the sectioning automatically. And if you want to return to manual, you can always use the hand wheel. So that's the new design of the cassettes, and then the new block holder. So as I was saying, if you wish to switch from high profile to low profile for this particular unit, is very easy. Just unscrew this screw and the other one there, slide out this particular metal block, and you'll be able to now put high profile blades easily. But for low profile, they can easily fit through here. And then you also have the waste area that usually connect it here so that you can be able to brush off your wax and then dispose. So it provides a very good working area for that. Then this is the automated slide stainer. So you can have two models, either SS30 or the SS30H. So the H comes with a dryer. So H means that at the end of your processing here, you can input a dryer, and there will be hot air that comes from here. So your slides will come out very dry. Or you can just have the SS30 where you just have to let it drip. But if you wish the configuration for the dryer, it comes in here. There's also a carbon filter that will absorb the fumes, and this one is very user-friendly to remove. You have the moving block here, so it will move this particular tissue at a go, and then you can also process up to 5 different slide holders at a go. So if you have here slide 1 containing another process, 2 another process, you can still load up to 5. So you can have different tissues undergoing 2 different programs. So you can have program 1 for H&E, you can have program 2 for Papa Nicolau, and it will be able to process it automatically. So this is the auto slide stainer, very ergonomic keyboard. You have a screen that will be able to give you the processes and so on. So once you set it up, you'll be able to move this until it gets to the end. Once it gets to the end, you'll have an indicator here that will tell you will need to remove the slides out, or you'll have an indicator here that means the slides are correctly put in. We also have the automatic tap that will be you can connect so that it will automatically be dispensing water and overflowing out and clearing to the waistline. So we can connect our tap here, and there's water that is supplied at 30 bar of pressure, which is very okay for proper slide cleaning process. So usually this one will have the water connected there. So we can store up to 20 programs with up to 50 steps in each. So once you set up your program, you load it. This is the indicator. You have 2 loading stations, so you can have load station 1, station 2, and so on. And then you can interchange as it moves. You can interchange and continuously load or continuously feed. So as it has moved the other processes, it will still come back and pick and remember which process is for which one. So after lifting up, it allows shaking. So this one ensures the way we do the step manually. So this ensures this. So for very busy labs, it's very important if you just have an automated unit to help you in that particular process, and this reduces the workload on the histotechnologist, and you can process more samples as this process is going. So as this process is being done, you can still be at your grossing stage, and you do your grossing, take it to the STP as these other processes are going on. So it reduces a lot of work process. So this is the carbon block filter that we said. So there are 2 blocks and can be replaced by the user at any point is just to unlock the magnet. This is just held by magnet, and then you pick it up and so on. So I said the last stage will indicate if the holder has reached there, and you'll have the auto stain dryer on that particular side, which can heat up to 60 degrees, depending on how you wish. So these are the washing stations. This is where the water, so as it overflows, and you have a tap that does that. So this will continuously allow clean water to clean those particular slides. So you have 3 unloading stations where you can put, and you can see the indicator that indicates and alerts you at the lab that now your slides are ready. You can remove them. We can also set programming on the computer. So those are just the features that we have discussed, and those are the microton blades, so either the high profile or the low profile. Now, the other part is on slide printing or cassette printing. So remember, currently, if you are using the manual method of labeling the cassettes or the slides, you can still have an automated process. So for the slide printers, we have 2 hoppers. So here you can just load your slides. So remember, just pick the slides from the box, load them here, and load them on the 2 hopper if you are so busy. And this will be able to select the printouts for these particular slides. So you'll just get your slides printed out here. We have a scanner down here that can scan the slides or the cassettes. So you have dual hoppers for 2 or 1. So it comes out with this particular quality where it can permanently laser print or edge that particular information of your cassettes in the slides. So it's suitable for different colors of slides and cassettes. So this is the cassette printer. So you can have multi-hoppers or a single hopper. So just briefly see how it does. And if this is your print quality of your cassettes. So just a brief of how it operates.
Increase your accuracy and efficiency in your laboratory with the PiSmart On-Demand Cassette Printer. Quiet, easy to use, and fast, the new StatLab PiSmart Cassette Printer is the perfect addition to your laboratory workflow with 2 compact options to meet your needs. The PiSmart 6-hopper printer is suitable for batch and on-demand printing, allowing different types of cassettes to be chosen from the on-screen interface or automatically through an LIS. The PiSmart single hopper printer is designed specifically for on-demand printing. Additional hoppers can easily be swapped on and off to allow for use of multiple cassettes, and single cassettes can also be inserted manually, bypassing the hopper entirely. The small footprint of the PiSmart printer makes it easy to print cassettes on demand right next to your processing station in as little as 3 seconds, the fastest printer on the market. A built-in scanner can read 2D barcodes from patient samples or test requisition forms, immediately triggering printing using a touch-free option. Printing right at the grossing station prevents errors, increasing the standard of patient care, and user login and sample traceability provide more insight when it's necessary to perform a root cause analysis. The PiSmart prints a 2D barcode and up to 85 alphanumeric characters on each cassette in dark, high-contrast, thermal transfer printing. Printers can connect easily to a laboratory information system by Ethernet or USB connectors. Thermal transfer printing is resistant to chemicals and heat, and paired with the protective design of patented PiSmart cassettes, you can be confident that printing will remain highly legible throughout processing. PiSmart cassettes are designed and validated for use on the PiSmart printer and contain pips on the cassette surface to protect printing during dewaxing. Cassettes are available in multiple colors and styles on easy-to-load threads of 40 cassettes. Whether on-demand or batch printing, the PiSmart cassette printer is your new affordable lab automation partner.
Cassettes. Now on to the slide printer.
Say hello to smarter lab management with PathSmart. The PassSmart tracking solution controls all of your PiSmart equipment while connecting your processes, transforming your lab to be faster, smarter, and more connected. The PassSmart Hub links all PiSmart slide or cassette printers to one computer in a lab, syncing user management, templates, software updates, and more. The PiSmart slide printer is fast and reliable, featuring a built-in scanner, onboard template designer, and flexible connectivity options. All packed into a small footprint, fitting right by your microtomy station for on-demand printing. Dual hoppers allow you to efficiently print on 2 types or colors of slides, and can be programmed to print on a specific slide depending on the specimen type. A single slide feed allows users to bypass the hopper when needed. Next, can log into the printer with a quick badge scan, their initials printing on each slide printed if desired. The fastest print speed on the market, as little as 3 seconds a slide, means you're never waiting on slides to print. And the highest quality thermal transfer print means a dense, dark barcode that scans every time when used on thermal transfer compatible slides, like Millennia Command, Color View, or Telmo. When it comes to connectivity, the PiSmart slide printer connects to any LIS system, existing workflow systems like Vantage, or can be used as a standalone printer. Our application specialists work with your lab and IT teams to understand your needs and ensure a seamless integration. And the best part, we manufacture PiSmart printers ourselves, right in our Holgate, England,
and so on.
An ISO 9001 manufacturing center with highest attention to detail by a team who cares. We'll never stop improving, innovating, and creating the future of labeling and tracking in laboratories. We're on your team.
Okay, now lastly, we also have digital microscopes and able now to store even copies of the pathologist images that you do. So the Euromex trinocular microscopes provide that particular option. So this is a very good addition to a histology lab where you can have storing the cassettes, storing the slides, and also having to store the images. So this is very good in this current era of digital pathology, where you can just refer to anyone worldwide without having to physically ship the slides to the referral laboratory or the referral pathologist. You can just have those particular images sent. So we also do provide the auto slide scanner that you may need as a lab, and it will be integrated to maybe the pathologist network if they are in-house or they are out of your place of histotechnology laboratory. So we also do provide that as well. So that makes the end of our presentation. So if you wish to contact us, those are our details. And now I hand over the session back to Antony for the Q&A. And thank you for your attendance.
Thank you very much, Haroun and Susan, for the wonderful presentations. I will go through the Q&A session very fast because we have only 14 minutes. So I hope you're able to hear me. All right. I'll start with the ones on the chat box, and I think there are quite many. Eric Ogonda, okay. Okay. So they're just not makers. Okay. Nelson is asking, what is IHC in full? It's an abbreviation. So I think, Nelson, that is immunohistochemistry. So unless Susan want to expound more on what IHC is.
Good morning once again. My name is Sarah.
Oh, sorry, Sarah.
Yes. So I'm very sorry, the team. I didn't remember to say immunohistochemistry. Instead, I said IHC. So this is just like the tumor markers test when you do after you've gotten your report. So once you've gotten the report that the patient has this type of cancer, for example, cancer of the breast. Let me not use abbreviations. Cancer of the breast. They are the tumor markers that will specify exactly which kind of chemotherapy should this patient get. So this test is called immunohistochemistry. which I'm calling it in a short form, IHC. Yes. If I get a chance in the future, I can give a presentation on immunohistochemistry for either markers of the breast or the lymphomas.
No problem.
Yes.
I think we can have a session for that in future.
Yes. Okay.
The question is from Joseph Ombayo. He's asking, after all that work, you don't report what you have prepared so that a pathologist can review your findings. I think Sarah had already highlighted that it's a beautiful work and everybody can always fit in the whole ecosystem. Benjamin, well done, Sarah, well-organized presentation. Tony, thanks for the good lesson. I think many are appreciating. And then Josephat Busiri is asking, may I use buffered formalin or even normal can still work? So Sarah,
I can answer that one. No more without doing the buffered formalin, it still work. But remember, even in other departments, what buffers do, they maintain the pH. So if it's buffered, it's going to work better, even for a bigger workload. Like for example, we are saying these tissues will be fixed around at least 8 hours. If it's buffered, 10% buffered formalin, even if you extend the time for fixation, they still fine. But when you're using the actual 10% formalin minus the buffer, you have to check on the timings because if it gets too acidic or too basic, it cannot work well. Plus, also you want to make the formalin a bit neutral for your sake, for the sake of the environment. So it's good to use 10%, but I know most labs do not have the source, the buffer source for making the 10% buffered formalin. But even if you use still the 10% formalin minus buffer, it will still work. But it is ideal. It is the best, the one for choice. Use 10% buffered formalin. Yes.
Okay. Thank you for that, Sarah. Rose Jebet is saying, is it possible to report your finding? Then the pathologist can review. I think it's been a fight for a very long time, but maybe you can chip in, Sarah.
I do not see a big deal with the reporting cases. Having worked in this lab, this kind of a setup for over 10 years, it's possible to, I've come to understand the morphology, how the cells look like. But why would I go fight for this with these guys for what they can do when I already have much to do? Remember, I said the techniques are more practical, more technical. I'm a technical person. I like it being a technical person. I'll do the technical part of preparing the slides. It's not like I should not report, but why report if there's someone who has come to report them? I think it's just fair to divide this work. It's not like they're coming to take my work or anything, but I feel it's fair. It's well work distribution. Can do even nowadays. The histotechs are training on grossing. The histotechs are training on these issues of pertaining the pathologist. So it's not like we are going to compete with these people only. According to me, I don't feel much threatened if they do the reporting. Still fine with the technical part. Remember, you have a lot to make sure these quality slides are out. You have a lot because you still check them in the microscope. You still do the microtomy, which I said is a technique which is also serious. So you have a lot on your plate. Why would you want to go add extra work anyway?
Thank you, Sarah, for that. I normally say the lab ecosystem is there's so much to do. So we just need to create that ecosystem. What type of ink markings are reliable?
You can use Indian ink. You can use even the eosin. And the best is eosin because remember we are going to do hematoxin and the eosin already. But Indian ink comes well when if you're doing a mastectomy, for example, or the resection margin for colon and the tumors of the bowel is of stomach. Just use Indian ink. Yeah, you're just going to ink the margins. You know, it's not like you're applying everything. Just ink the margins so that you can be able to see them, visualize them well once you're done with staining. Yes.
Thank you for that. What are the effects of xylene in histopathology?
I don't know whether you want the good effects or the bad effects, but one of the effects with the xylene It's a good clearing agent. It will clear everything. Once you're done with your xylene is fresh and you cleared your slides with xylene, they'll appear very clear, very clean when you're doing the mounting and microscopy. But it also has an harmful effect. It's carcinogenic. And with experience, even when you put on gloves, when you touch xylene, they'll tear the gloves. So it has also the bad effects, but the good effects, it helps with the slide, clarity of the slides. Yes.
Yeah, I think that alternative to xylene, especially on it being carcinogenic nowadays. I don't know that you want to comment on that, Sarah.
Yes, there's an alternative for xylene. Unfortunately, what is available in the market mostly, and what is I think what is affordable is the xylene. But you can always use another mounting measure.
Yeah, I've always come across some of the alternatives in the market. I don't know, something chloroform based or something. I'll check with one the distributor that we are distributing for. They have something. I'll let you know, Mr.
Even in our lab now we are doing aqua mountants. So you do not have to use the xylene part when you're doing like once you're done with the machine, done with the staining, you not do the dehydration part and clearing with the xylene. You just dehydrate and mount with aqua mountants. So you avoid the xylene that will come into contact with you. But what I did emphasize, team, is the only bad thing with this reagent is overexposure. So even if you expose yourself with xylene for let's say like 1 hour or so, or even formalin, it's still fine. But if you ever expose yourself to these kind of reagents, that is when now the carcinogenic part comes in. Yes.
Okay. Thank you for that, Sarah. Let me check the compliments or share the notes. I think that one Haroun can stay in touch. Good presentation, nice and impactful, nice presentation. So I bet all the questions in the chat box are done. So we still have 5 minutes. So if you have a question, you can unmute your microphone and ask a question. There is Levis. Levis, proceed. You can unmute your microphone, Levis.
Yes, good morning.
Good morning.
Thank you, Sarah, for the nice slides. I guess they were very clear to everybody. I just have a question still on inking the margins of the section. When you use, for example, Indian ink, is it that one type of ink is applicable for any type of tissue, or there are some tissues that nicely tolerate Indian ink, while maybe others can tolerate best the current surgical inks in use? Is it that one ink can be used for any type of tissue, or you can vary them depending on the tissue that you have? That's the question I have.
Exactly, you can vary them depending on the tissue you have. I mentioned Indian ink because it's readily available. I think you're using it for other departments. It's used in microbiome, if I'm not wrong. So Indian ink will work for most of them, but it varies with the type of tissue you have. Even the inks, nowadays that it's in the market, they are selling different types of inks for the margins. Yes.
Okay.
Thank you very much, Levis. Anybody else? Let me just see on my list. Okay, I think it was only Levis whose hand was up. So feel free. All right. If there's nobody else, so I think histology is something that is coming up quite well. I think it's being appreciated, it is expanding, and I think with a lot of cancer issues that we have in the country, the cancer burden, we need to confirm. And histology is one of the lowest lying entry foot levels in terms of laboratory diagnosis before we go to other complex molecular techniques. So most labs are embracing it more, and if there's an opportunity for you, if you want to set up an histology section, you can start small. You can start with maybe a tissue processor. You can still do the other parts manual, and then you move towards the other side slowly by slowly as you build up. But if you also well endowed resource-wise, you can do the end-to-end. So we are able to provide for you as Keton Group the tissue processors, the embedding stations, the stainers, the printers, the microscopes, and the whole ecosystem for histopathology laboratory. So we are also in the final stages of just seeing whether we can also craft an EQA program for histopathology, so that we are also able to include it in our menu. It's something that we've always had an ask for a very long time. So we are still in the discussions with our partners in Germany, that is European Society for EQA, so that we can see whether we can also strengthen the external quality assurance models for EQA. There are some that are already existing, but we are working on ours. So having said that, I don't think there is any other questions, so I'll take the meeting back to Haroun and then thank our presenter for today, that is Sarah Mumbua, for the wonderful presentation and for the engaging job, and the very many participants we've seen today. And we want to wish you very well. So over to you, Haroun.
Okay, thank you, Antony. Thank you, Sarah, for the wonderful presentation. I think the next ask is on IHC. So we'll be able to schedule that, and we'll be able to share it on our webinar series sometimes in the future. Isaac, we usually do upload CPD points for attended participants automatically within 24 to 48 hours. Mohamed Damisi, your comment was noted. We will also share the video link for YouTube for review. In case you missed anything, the session is recorded and we upload them on our YouTube webinar series. So you can always go back there and refer, or you can also share with your colleagues who maybe have not been able to attend. Lastly, all the equipments that we have discussed will be on show. So in October, so we'll have the first one at WHX Nairobi, which was formerly MedLab East Africa. So you can be able to visit our Maya booth, and we'll have all the histology, automated histology equipment on display. And you can also visit our booth at Akamoso at the end of October, where we'll also be having a display booth for the solutions we offer. Thank you so much for making time to attend on time and attending through the whole session. We appreciate your indulgence, and see you next week for another webinar series. Thank you.
Over to you, Sarah.
Thank you very much for listening. I really appreciate it. I have not presented before. I really appreciate for the chance and the opportunity to present. And I would really want to participate in our EQA program. This is our dream. This is where I'm trying to go next. So that even our lab, when I give out slides, I'm sure these slides are as good as some done in South Africa and even in other countries. I really want to participate in the EQA program. Thank you very much, team, for allowing me to present, and may God bless you. Bye.
Thank you very much, Sarah, for the wonderful presentation. If it's your first time, that's a very wonderful productivity that you've shown there. And as Haroun has said, we'll be able to participate in the MedLab East Africa at KICC in the month of October. And then we'll have a session in Mombasa during Akamulso. And then we're in the final stages of also presenting at the KACP conference, that is Kenya Clinical Pathologist Conference, that will also be happening in Mombasa later in the year. So we have a lot of series of display for equipments and also for histopathology solutions during those particular sessions. So if you get time to be in those sessions, feel free to indulge us in those particular booths. So I want to thank you and wish you well. And this is our 9th series of the webinars. So we'll be having the next one next week on Thursday, same time. All the best and God bless.